Hello and welcome everyone, and in this video we will be discussing some more properties of steel sections and then making of complex sections out of simple sections. So what I have opened is the Annexer H of Indian Standard Code 800, and at the left if you see there is the list of index and there are so many titles, and I have just opened Annexer H. So what I will do, close this index, paste. This is from the Indian Standard Code 800. Okay, so actually Annexer H contains only 3 page table, and there is properties of sections, but they are limited in numbers. Okay, so only beams and channels properties are written here. So there are different sections. So where are those properties written down? So the properties of all the possible sections as per per the Indian requirements, they are laid down in the steel table booklet, and that is a government handbook and we can also buy it. And in that booklet there is a number of tables, list of tables, and in those tables we can find out any properties of any section that is available in India. So if you do not have, then you can have access from the Indian Standard Code few properties of few sections. So at the leftmost, if you see, the first column is written here as designation. So this is the designation of different channels and beams written here. So if you see, the names are designated as ISWB, ISMB, ISLB, like this. What does it mean? It means Indian Standard wide flange beams, Indian Standard medium weight beams, Indian Standard light weight beams. So we know the shape of the beams looks like this. This is a rough diagram. So what is this digit 600, 500, 550, 450 followed by the designation name of the steel section? This is the depth of section, and we know the depth of section is the distance between two flanges, capital D. And here also it is written in this table, this column is depth of section represented by capital D, and the unit of depth is in millimeter. Okay, this is very important. So the 4 parameters that we discussed about the I-beams, which is depth of section, width of flange, thickness of flange, and thickness of web, they are being represented by BF, TF and TW respectively, and their all unit is in millimeter only. Okay, so all these 4 properties you need not to remember or calculate, but they are given in these tables and you can directly take values from here. Like if I take ISWB 500, okay, I am taking Indian Standard wide flange beam which is of shape I shape, and 500 means D is equal to 500. Okay, so you can also look at this, it is 500. Okay, and then the width of flange is 250. This is the width of flange, okay, BF, and this is 250. Then the thickness of flange is 14.7 and thickness of web is 9.9. You will be also be surprised to know that this table also make us aware of sectional area. What is sectional area? Sectional area is the area of the cross section. This is the section and we are taking the area of entire section. So this sectional area is in centimeter square, and we can directly get the value from here, 121.22 centimeter square. And the weight per unit length of steel section is also written in kg per meter. So 1 meter length of ISWB 500 weighs almost 95.2 kg. So in this table you will also see some more values of some more parameter like radius of gyration, RZ and RY. You know there are 2 axes, so there will be 2 moment of inertia and corresponding to them there will be 2 radius of gyration, and the unit is in centimeter, not in millimeter. Okay, and then there is section modulus, and then there is plastic modulus, and the ratio of 2 is called shape factor. And shape factor is basically used in plastic analysis, and this shape factor is always greater than 1. This is the property of shape factor. So mostly we are concerned with these 4 parameters: capital D, BF, TF and TW. Okay, so after seeing all this data, you will also see some names like ISLC, ISMC, ISWC. What does it mean? So ISMC means Indian Standard Medium Weight Channel. Okay, Indian Standard Lightweight Channels. And we know the shape of channel is like this. And the data you can directly get from these table. Okay, all the 4 data which are most important for us. So after understanding this table, it becomes very easy for you when you go for the calculation or analysis part while designing. So now moving to the theory part, and here we have already discussed in detail that steel sections are rolled in industry in the standard shapes. That's why they are called rolled sections. And that's why I write before any name rolled beams and columns, rolled channels, rolled structural shapes and dimensions, like this. Okay, and then there is plate, and this is just the thickness of plate being shown here, and plate is generally of shape 2-dimensional. Okay, this is like a plate, and plate has thickness very less in comparison with the 2-dimension. Whereas flat is exactly like a scale. Its 1 dimension is very large, length is very large, whereas the breadth and thickness is very small. Okay, this is called flat. So in flat, 1 dimension become very large. In plate, 2 dimensions like A and B becomes very large in comparison with the 3rd dimension, which is thickness. Okay, so this is very easy to understand. So these are all the simple sections that you can very easily get from the market, and you can make simple things out of them. But if suppose you are a site engineer and you need a steel section which is really very tough, stiff and very high strength is required for carrying very heavy load, which is going to come like on the bridges, decks, or some heavy structure is required to be made. So in those cases you can't use these simple sections, isn't it? So what do we do? So in that case, when the heavy load is going to come, then we have to make the steel sections little complex with the help of these simple sections. So there are 3 ways of making complex sections out of these simple sections, and those sections are called compound section, fabricated section and built up section. So these are the 3 different complex sections which are made out of simple sections. So they can very easily satisfy the requirements on the site, which is actually the heavy loads. So the first one is the compound section. Compound section is made by putting a cover plate over an I section. This is very simple to understand. Now in the figure, if you see, I have only shown you 3 diagrams of compound sections, and there is no I section being shown here. But if you look, I have shown you the kink here. Kink is the continuity line, and I have not shown you the full diagram but only partial, the top one. And what I have done there is that I have covered the flange of the I beams with another cover plate. Do you see this? And in the first diagram, the width of the cover plate is exactly same as the width of the flange of I section. Whereas in the second diagram, width of the cover plate is smaller than the width of the flange of I beam. Whereas in the third figure, width of the cover plate is really larger than the width of the flange of I beam. So these are the three different ways of making compound sections with the help of cover plate and I-beams. So what happens by making compound section? You can very easily see the width of flange is increased and the cross-sectional area is increased. And of course, the thickness is also increasing for the flange. So by this, the strength, load carrying capacity of the section will increase. So this is the benefit. But if even we are not satisfied by compound sections, then what we can do? We have to go for fabrication of sections. And this fabrication of section is mainly done in case of girders. Now what are girders? Girders are basically beams, and they are heavy beams being used mostly in the industries, and those shapes are like also I-beams and rectangular or a square hollow beams. And girders are made out of simple steel plates, and their steel plates are connected with each other with the help of welding. And you can see these are the welding being done at the corner. Do you see this? So this is the welding being done at all the joint. So in the first figure I have shown you I-beam which is fabricated with simple plates, steel plates. So do you see the difference between fabricated section and normal I-beams? There is a lot of difference. Okay, in I-beams normally here it is smooth, okay, but in fabricated section you can't do this. Whereas in the second figure we have also added some more extra parts here at the end to increase the more sectional area. Okay, and in the third figure you can see we have welded 4 steel plates in such a way that ultimately we have made a square hollow tube. Okay, and this can be used for the girders in the industries or the cranes. So this is the fabrication of section, and this can be also be done at the site also. The third way is the built up section, and built up section is actually can be made by 2 or more than 2 simple sections by joining them in such a way that we get a different section altogether. Like if we take 2 angle section, just like in the first figure we have done, and when we put 2 angle section back to back, and it forms like a T section. The both angles are welded with each other here, and the dotted line is showing the welding. Similarly, in the second figure you can see 2 channel section are brought back to back, and they are welded at the both ends. This is the dotted lines and welding is shown here, and ultimately we have got a I section with the help of double channel sections. So those sections are called built up sections, and built up section have more strength than the simple sections. Okay, so all these 3 types of sections that we have just discussed, they are basically used when there is heavy load is going to come on the structure. All right, so now let us discuss some advantages of steel as a structural material. The very first advantage that can come to our mind is that steel has got very high strength per unit weight. Now what is the per unit weight? Why it is written here? And if you cast a beam with the help of 5 kg steel, and if you cast a beam with the help of 5 kg concrete, strength of steel member will be more than the strength of concrete member. That is very obvious. So the strength is very high and the weight is very less. So if the weight is very less, the dead load will be very less. So the unnecessary loading on the structure will also decrease. So this is additional advantage. The small sections, little self weight. Okay, the same thing is written here. Sections are small and the self weight is less. Members resist heavy load and smaller column sections, and the number of columns will also be decreasing. Also, steel members can be easily transported, and we can prefabricate these steel members on the industries itself, and we can transport it to the site and directly use without any delay. And steel being a ductile material, it gives sufficient warning or alarm before the actual failure occurs. So there is no risk of sudden failure in a steel. Okay, And steel, being a very flexible elastic material, can be bent, hammered, seared, or even the bolt holes may be punched without any visible damage or crack being appearing on the steel members. So if we properly maintain the steel, those steel structures really have a long life. And steel properties mostly do not change with time. And additions and alterations can be made very easily and can be erected at a faster rate. Very beneficial thing is that even if we break or remove or the entire structure, the scrap value of steel is the highest amongst all the building materials, and those steel can be reused and recycled very easily somewhere in the industry or some other site. All right, so these are the very prominent advantage of steel, and that's why it becomes popular amongst all the building materials that is possible for construction. So now let us also discuss some disadvantages of steel as a structural material. So when the steel is exposed into the external environment, so when it comes in contact with water, it has probable risk for corrosion if we have not properly painted or applied some non-corrosive techniques or maintenance. So it requires painting and maintenance. Okay. And what happens if there is fire hazards in steel structures? So the one thing is that the strength reduces very drastically, very fastly in the steel structures, because at high temperature the steel loses its properties. So all the steel structures needs fireproof treatment. So it of course the additional cost on the construction will increase. Now the third disadvantage is that steel is an excellent heat conductor and also the conductor of electricity. So it may transmit heat sufficiently from a burning location to the adjoining room. And now the fourth disadvantage is fatigue. Fatigue is what? Fatigue is actually the reduce in the elastic or the yielding strength due to the repeated loading. Loading and unloading. Due to this, the strength of steel reduces with time. So this is called fatigue, and this is one of the major disadvantages of steel. Fatigue at very low temperatures aggravate the situation. Okay, so this is very clear. There are four main disadvantages which we have discussed. The corrosion, fireproof treatment is required, and then the excellent heat conductor and the fatigue. Okay, now let us also understand the stress strain curve for steel, and this we have already discussed clearly and explicitly in a separate video. You can watch that, and all the points and region I have already discussed in one more video, so you can again have a look to those videos. The steel has same curve either in tension or even if you apply compression on a steel, the stress strain curve is not going to change. Okay, tension or compression, the curve will remain same for the steel. Actual behavior of a steel is different and indicates an apparently reduced yield stress in compression. So in actually, yield stress is little reduced in compression. And divergence from the ideal path is called Bossinger effect. You can read from the text. And the ultimate strength is the maximum strength that the steel can withhold, and that is written here: ultimate tensile load divided by the original area of cross section, and this is in the unit megapascal. So there is some ultimate strength and actual ultimate strength. So we have already discussed this characteristic stress strain curve and true stress strain curve. So in that topic we have discussed this. We have discussed ultimate strength as well as actual ultimate strength, and characteristic ultimate strength is also discussed in another video. So you can have a look on all these graphs and this famous formula. FCK is equal to F mean minus 1.64 sigma. Sigma is the standard deviation and F mean is the mean value of all the data that we get, and this is the characteristic curve. And the ductility is also explained. Ductility is the capacity of a steel to undergo large inelastic deformation without significant loss of strength or stiffness. And the percentage elongation, which is related with ductility, and this is explained here as the elongated length minus gauge length divided by gauge length into 100. So this value comes out to be percentage elongation when multiplied by 100. And gauge length is related with the area of cross section, like this. When we take the area of cross section A0, so the gauge length we have to take not very much, but it should be the function of A0 under root multiplied by 5.65. And when we put this gauge length under a experimental setup and we elongate it, and then the elongated length minus gauge length divided by gauge length, and when we multiply it by 100, we can easily get percentage elongation. So, and you can also read the definition of toughness, and toughness is the capacity to absorb energy. Like you have done some Los Angeles test, and you in that you measure the toughness of the aggregates being used in the road constructions. So capacity to absorb wear and tear energy, and this is the measure of fracture resistance under impact. Okay, the modulus of elasticity, this is very important. This is very important. Modulus of elasticity of steel, which is represented by capital E here, and this is equal to 2 into 10 to the power 5. Okay, 2 into 10 to the power 5 megapascal. Just remember this value. Okay, you may remember Poisson's ratio is equal to 0.3 in elastic range and 0.5 in plastic range, but you may forget this value, but you should remember the modulus of elasticity of steel, which is 2 into 10 to the power 5 megapascal. And then there are two types of steel sections based on manufacturing process, and we have discussed it also. The one is the cold formed section and other is the hot rolled sections. And cold formed sections are also light in weight, and they are used for smaller loads where hot rolled becomes uneconomical. Because cold formed, just you take a mold and you power the molten steel and you just put it in the cold storage where it slowly cool down, quenched, and we can make any section from this method. Whereas in the hot rolled section you have to pass the red hot steel, almost semi-solid, and those rollers it takes a different shape, so this is little costly. And the hot rolled section has a very definite shape, and there is no patches on the external surface. Also different designation also given for different sections. So in rolling mill the hot rolling process is done, and due to hot rolling there is no loss of ductility. Okay, but there are different sections, and we have written down few sections only, like Indian standard junior beam, Indian standard lightweight beam, Indian standard medium weight beam, Indian standard wide flange beam, Indian standard heavyweight beams, Indian standard column sections, Indian standard junior channels, Indian standard lightweight channels, Indian standard medium weight channel, and then Indian standard angles, Indian standard normal T sections, Indian standard deep legged T sections, Indian standard lightweight T sections, Indian standard medium weight T sections. So you need not to remember all these names, but if you look, most of the things will be very clear to you. Okay, so we will discuss more on the loads and the design philosophy in the next video. Till that, stay tuned and stay safe. Thank you.